Perfect. Awesome. Thank you. So yeah, this is heat pump water heaters for your home and small business. I'm John Kenney. I'm the energy management technical specialist over here at LPEA, mainly focused on our contractor relations, rebate programs, and I'm also a good resource for you all as members for learning opportunities like this, for webinars, and then I'm always here to answer any questions that you might have as you're moving through projects like heat pumps, heat pump water heaters, electrification, things like that. So my contact info will be at the end of this presentation. I'm always happy to talk either by phone or email. So I'm always here as a resource for you all as members. So tonight, so what we're going to talk about, so heat pump water heaters. So we'll go through some various types and how they perform, kind of savings and things like that around them. We'll look at actually how to install some of these, how to take on a project and get one of these installed in your home. We'll look at installation best practices so you can actually kind of figure out how to best guide a plumber or yourself how to install one of these. We'll look at the LPEA rebates that we offer to help offset some of the costs of these systems. And then we'll also look at some federal and state tax incentive programs. And then I'll open it up for questions. So I'll try to leave a bunch of time here to answer any questions you all might have on specifics out there. So I always like to point out, LPA is kind of more than just an electric company. We are a not-for-profit co-op utility. So that means that you all as members are actually part owners of the co-op here. And so what would typically be profit for a company each year is either reinvested into the co-op or it's returned to you all as capital credits and you get a check in the mail. So a little bit different than some of your investor-owned utilities out there. And then you can kind of see our mission statement there. And really, it's not a focus on how much money we can make. It's really on what kind of service we can provide to you all as members. And then we've got that strategic goal there that does have kind of an environmental component behind it, which we see as helping the community as well. So one thing you've heard from us, hopefully here, and you'll hear more, is this idea of beneficial electrification. So electrification really is moving away from fossil fuels, so gasoline, propane, natural gas, and electrifying that equipment. But we want to do this in a responsible way. And so these three things down below here, saving you all money over the long run, truly benefiting the environment, and then keeping the grid resilient and robust. We want to make sure that the things that we're proposing here are going to bolster one of those things without negatively affecting the other. So we want to make sure that what we're telling you to do is going to save you money in the long run. That it's not going to cause brownouts and blackouts on the grid and voltage issues, and that it really truly is going to help the environment and reduce greenhouse gas. So just kind of the heat pump basics. So all these things that we're going to talk about tonight do have a heat pump on them. And if you haven't been on one of our other webinars here for some of the heat pumps, at its most basic level here, a heat pump isn't really creating heat as you would think with a traditional source. It's really moving heat from one place to another. And that's why we can have such high efficiencies with heat pumps, and really why they've become so popular lately. So on the left-hand side here, this is kind of the cycle that a heat pump goes through. So on the left there, you've got the blue evaporator coil. So that's actually going to pick up some heat. It's going to take that refrigerant that's flowing through there, add some heat to it, start to put some pressure in there. And then we pass that through a compressor. It changes to a gas. It's now high temperature. It goes into that condenser, which has another coil on it, which, if you're familiar with mini splits, that would be heat being passed into your home. Well, in this case, we're taking that heat and passing it into the tank for hot water. And then that gas is going to leave that condenser unit. It's now cooled down a bit, goes through an expansion valve where it turns back into a cold liquid, and then it starts that process all over again. And on the right there, you can kind of see this is a typical heat pump water heater. It's a unitary model that we'll look at here coming up in a minute. But essentially all it's doing is pulling warm room air in. It's passing all that heat through a heat pump assembly down into that tank and then exhausting cold air. So at its most basic, that's kind of what's happening on most of these heat pumps. So we're going to look at kind of just all the various heat pump water heaters that are out there right now. um, to give you a bunch of options so you can pick kind of what's going to work best for your situation. And the first one we're going to look at here is what we call unitary heat pump water heater. So this is kind of a packaged unit. So what you're seeing here on all these different models is a standard electric resistance tank with a heat pump assembly on top of it. And so all of these are going to pull that room air into the top intake on that heat pump assembly, pass that heat down into the tank, and then exhaust cold air. And you'll also hear these called hybrid models, and they're hybrid because the two little bulges that you see on the front of each of these tanks, that's actually where a set of electric resistance elements sit. So if these systems can ever not keep up with the heating demands on the heat pump, they can actually turn those electric resistance elements on to ensure that you have hot water all the time. Some of the kind of pros of this and advantages, these are probably going to be the lowest cost option that we're going to look at here tonight. The installation is fairly simple on these. There's a couple extra things that we'll talk about later on that you need to consider. But from an installation standpoint, this is about as simple as it gets. And these are widely available. This is not a complete list here, but these are kind of very common these days. So you can go to Home Depot, you can pick these up at any of your kind of local distributors here, the plumbing distributors in town, or order these online, and you'll find a lot of different options out there. Price is coming down pretty fast on these as well as they become more common. The downsides to these, so we'll talk about kind of just pros and cons of all these different systems, and for these, there's a few. One is some people are sensitive to the noise that these do produce. I like to think that these produce about as much noise as a quiet dishwasher or maybe a freezer. Some people are more sensitive to it, especially if you end up mounting this near a bedroom or somewhere like that where it's really quiet at night and you can kind of hear this thing come on. But for the most part, it's quite quiet. And so I think if you just install it in the right location, it's not too bad. The other downside to this is we are using conditioned, warmed room air to heat that water. So during the heating months, we are using what the HVAC system is producing in order to heat water. So we're kind of robbing from the HVAC system to heat water. I think there's still an advantage there, especially if we're using something like a heat pump to heat our home as well. And then in the off-season months where we're not heating that home, a ton of gain on energy efficiency there as well. So, we'll look at the savings numbers coming up here later, but even with taking some of that load from the HVAC system, we're still coming out way ahead on cost to heat water throughout the year on these. But do be aware that where you mount this system, it's going to exhaust cold air, and it's going to drop the temperature in that room by a little bit when it's producing hot water after you take something like a shower. And so these work really well in places like garages, utility rooms, or basement if you have one, where you don't really mind that cold air. But if you're trying to mount this somewhere where you're going to be sensitive to some cold air blowing in there, you might consider one of the other options we're gonna look at here. So that's the unitary system there. This now is the split heat pump water heater option that we have out there. So the difference here is that we've now taken the heat pump assembly off the top of the tank, and we're going to move it outside like you would see with a standard mini split heat pump. And the advantage there is, one, we're no longer using the HVAC system to steal from to put heat into that tank. We're actually just going to use the outside air. We're taking all of the noise and putting it outside the home. So, if you're sensitive to noise inside there, this can be a great option. And we still see a lot of really high efficiency on this. So if you've seen a mini split heat pump system before, this outdoor unit typically mounts either on the wall or on a concrete pad outside. And in this case, both the indoor unit and the outdoor unit are all mounted inside of this monoblock design on the outside. So all the refrigerant is outside the home. And then the connection to the inside storage tank, where we're going to keep all that hot water is actually a hot and cold water line. So that kind of cuts down on the installation cost a bit, and we don't have to mess around with the refrigerant running through a line set there. I've seen these rated down to about negative 20 degrees Fahrenheit. So if we derate that for our altitude here, you're talking negative 15 degrees Fahrenheit that will still produce hot water. And so I think we'll see the performance on these pick up even further. The downside to these, so these do cost quite a bit more than the unitary models that we looked at previously. They're not as widely available, but I think that's changing. I think this is a great option, and I'd really like to see the market move towards these more, just for space constraints and having all the noise and everything outside. I think this is a great way to do it and not have to have that cold air blowing into the home. But just do be aware of that if you're gonna pursue a model like this, that it does come at a cost premium. And then the next one. So this is brand new. In fact, it's not even going to be out until next year, but they do have now an on-demand version of a heat pump. So we've had electric resistance on demand for quite a while now, but this is going to be the first time that they've actually been able to adapt a heat pump to it. And so what's happening inside here? There's actually two high temperature glycol storage tanks that help support the heat pump for on-demand water. And what we're looking at here is this is from a company called IntelliHot. Two different systems on the left and right. So on the left, they have actually just packaged the whole thing together, and that can be mounted either indoors or out. And so it's the entire heat pump assembly, the storage tanks and everything, and you would just run the hot water line into your home. On the right, they've separated it out. So this is a little bit more of a high performance system. The heat pump assembly would go outside, and then that IB3 assembly, which is all the storage tank, would go inside the home. So just to split that out, and yeah, bit better hot water delivery there. Again, these are not available quite yet, but if you are interested in in an on-demand system, if you're space constrained, if your water usage is pretty low, this can be a great option coming up. I do think this is probably going to be at quite a cost premium. So these probably will be a expensive system, at least in the initial phase here as they're releasing this. And then kind of the last heat pump system that we'll look at here is what we call a combi system. So this is going to use a single heat pump outdoor unit to do both space heating and domestic hot water. So if you're already looking at doing something like in-floor heating or radiators or even these fan coil units, and you want to do an air to water system or even a ground to water system, you can add a water heater, storage tank, and get domestic hot water out of that same system pretty easily. And so while the system overall is pretty high cost, the adder to get domestic hot water out of that is not going to be too much more. You're going to have to oversize that outdoor unit a little bit, and then add some piping and valve and things like that onto it. But this could be a good option if you're already pursuing that for something like new construction. And then so this is not a heat pump water heater, but I wanted to put this option in there. If for some reason a heat pump water heater just doesn't work for you, you're space constrained, if it's not in the budget, or you happen to have something like a short-term rental or something like that, seasonal home that it's just not feasible to do a heat pump water heater in, then this is a kind of a backup option that I wanted to show you. On the right there, that's a Marathon water heater. It's just a standard electric resistance water heater. You could use any a standard electric water heater on this. Maybe you even have one already. And what we're doing is pairing that with this Aquanta control system. So it's the blue box there. And that's a Wi-Fi connected control. So it'll sign into Wi-Fi. You can actually control that from your phone. So you can turn the temperature up and down. You can put it into vacation mode when you're away. You can put it on a schedule to help avoid the peak power times here and save a little bit more. And so great way to control a standard electric resistance tank. save as much as you can out of that. And then I've also shown here that's that valve assembly up at the top is a mixing valve. So what you can do is if you are space constrained or you're finding that you're running out of hot water with your existing tank, you can put a mixing valve on there, turn the tank temperature up above that standard 120-degree set point, but the delivery temperature of water out to the home won't ever exceed 120 degrees. And so we don't have to worry about things like scalding because the water is too hot. But what that effectively does is it upsizes that tank. So a 40-gallon tank now is storing enough hot water to act like a 50-gallon tank. Because it's taking hot water, mixing just a little bit of cold in there to temper it down and giving you the same 120-degree temperature water. So again, this is an option out there that if the heat pump water here doesn't work for you, then maybe pursue something like this setup here. So costs. I'll talk cost before savings. So I don't like to talk costs only because things are changing so rapidly because a lot of this stuff is all brand new. And so we'll talk about how to install these things later, but certainly get quotes, get 2 or 3 different quotes. Shop online if you're going to purchase the equipment yourself and just see where pricing is at. I think it's going to change pretty rapidly over time here as adoption takes off. So yeah, the order in which I showed you the different options today is definitely ordered from lowest cost to highest cost. So you can kind of go with that as far as what you're going to pursue, but certainly I would say just do a bit of research, dig online and find out exactly what that's going to look like. From a savings standpoint, though, we can make some estimates. So, it's going to be kind of ballpark here. Obviously, it's different if you take 5-minute showers versus 30-minute showers. But this calculator here from Zwell Home is a website you can jump on and plug your own situation into here and your own specifics and get a savings estimate. But what this is really showing is that a natural gas water heater, which is kind of the best non-electric option out there, versus on the right-hand side, we've got our heat pump water heater. And so somewhere around $100 in savings a year is what we're estimating for a family of 4 taking kind of standard showers out there. And so you can kind of extrapolate off of that for your own situation of what that might save. And I think as we're talking about stabilizing electric rates and trying to keep those down as much as we can, we're also at the same time seeing natural gas, starting to fluctuate and certainly go up over time here. And so, how do you go about actually installing one of these? I think really it starts with, doing some research on your own, considering your budget and kind of making a decision on what you need out of that system and what type of heat pump water heater you want to go with, whether it's that unitary model or a split, just kind of based on your home and how it's going to fit in there and kind of what you want out of that system. And then I would say contact some installation contractors. So this is going to be a plumber. And in most cases, a plumber will either do it themselves or have a partner that does the electrical work on these things and, get 2 or 3 different quotes. I can also tell you that similar to what we do for the heat pump contractors today, where we have a list of quality install heat pump contractors on our website, we will have that coming up here for heat pump water heater installers as well. So we'll have a resource where you can go and find a contractor who's been through a short training for us to know how to install these kinds of things and how to work with our rebate programs. So that's a good place to start here. And that'll probably be up here probably in the next, I would say, month or 2. And then discuss with that contractor whether you're going to buy that equipment and they're going to just do the labor only, or if you're going to buy all the equipment, everything through them, and who's going to do the electrical work and things like that, just to arrange all the specifics around that. And then, have that water heater installed. Once you have that water heater installed, as soon as you can, put the controls set up in there, get it connected to Wi-Fi if it has that, update your settings, all that stuff, to try and avoid the peak periods. So for us, that's going to be 4 to 9 p.m. if you're on our standard rate, or if you're on the time of use, you've got that morning and evening peak, and that can just help to save a little bit of money. And you've got to think of that as, you're storing 40 gallons of hot water. Do you really need to immediately heat water right on the peak, or can you wait for that peak to be over before it starts to heat water again? And that's what that the control savings can do. And we'll talk a bit more about that here coming up. And then within 90 days of that installation is apply for the LPEA rebate up on our website. And then within 6 to 8 weeks, we'll send a check out to you, and I'll go through the rebates here coming up. And then there's also the tax incentives, so state and federal tax incentives that you can get for these systems come tax time each year. And then maintenance is really important on these. If they have air filters on them, typically they're reusable air filters that you just need to rinse off and stick back in there. If you have an outdoor unit, just blowing dust and things like that off, that can be good. And then something I think everyone knows they should do, but I think we're all a bit guilty of not doing, is you should really drain these tanks out once a year to get all the sediment out of the bottom of them, to keep them operating efficiently. So it's always a good idea just to connect a hose to it and just drain a bunch of water out to get rid of all the sediment that builds up in the bottom there. So we'll talk about just installation best practices. And these are all just things that we've kind of learned from doing some pilot projects and hearing other stories. And so, to start, be aware that you do need 240 volt, 30 amp circuits. You are, if you don't have it already, you're going to have to pull that circuit over there. So that's going to be some electrical work. They do sell 115 volt, even plug-in versions of heat pump water heaters. We don't recommend them specifically just because of the delivery temperature of water here tends to be a little lower. And so those systems tend not to be able to keep up. We'll talk about a mixing valve here in a second for a solution for that problem, but certainly I would say stick to 240 volt versions of these systems. I think they operate a lot better and you're gonna be a lot happier. If you're gonna go with the unitary model that we looked at first, just account for that cold exhaust. In some cases, you can exhaust it to the outside or into a crawl space or a garage, somewhere you don't really mind, but certainly keep it away from thermostats and other sensitive areas. We don't want that thermostat thinking that it's much colder. Otherwise, the other rooms in that house are going to run pretty hot. And then most of these, at least the unitary systems where you have the heat pump inside, they do require at least 700 cubic feet of space. So that's a 9x9 room with 9-foot ceilings is about what you need there. If you don't have that, you can always do some things like put louvers in the door or a vent in a wall or even a gap underneath the door, or you can put an 8-inch vent duct on most of these systems to pull air or push air into an adjacent room. So you've got options there if you don't have a big utility room or a garage or a basement for these, but just be aware that we don't want to suffocate these. We need to give them a bunch of air to move through that heat pump. And then don't block it. Don't stack a bunch of stuff up around it. Don't point the exhaust towards the wall or anything like that, so that it can move enough air through it. And then they do need to have a minimum of 4-degree ambient temperature. So we can't go put them out into an unconditioned garage where it starts to freeze, because they will stop operating on heat pump and they will go to that electric resistance mode, and you won't see the savings out of it that you're expecting. Consider the incoming water temperature. We've seen with a couple of different people, if you're on something like spring-fed water that's coming in the low 30s, that the heat pump will continue to operate, or it won't be able to keep up, and it's going to sit on the electric elements pretty often. And so you might not get the performance that you're expecting out of that. So if you are a user like that, that has really cold incoming water temps, do be aware of that and just kind of take that in consideration on sizing your system and the type of system that you select there. You may even have to do some preheating, things like that, if possible. And then these do have some condensate. So there is a cold side to this that's going to pull some of the moisture out of the air. And so you do need a condensate line to go to a ground drain or drain line somewhere nearby to get rid of that water. If you're going to put this into something like a basement or a garage, just insulating it from that slab. We don't want a bunch of cold, going through and having a bunch of heat loss through that ground. So even just a rubber pad underneath that tank can help to insulate it from the cold slab there. Providing sound mitigation can really help. If you have to put this somewhere that you're gonna hear it, especially at night when it's really quiet. You can do some things like using PEX piping instead of copper lines to help with the vibration there. Putting this up on a rubber mat just to try and isolate it. And you can even go as far as to wrapping all the pipes and everything, in the vent pipe, all that, to try and kind of limit the amount of vibration that's in there. And then even go as far as to put insulation bats, so fiberglass insulation bats in the room where it's at, just to kind of quiet that thing down. Or select a split heat pump water heater if you feel like that's going to be an issue, or mount this somewhere like a garage or basement where it's away from everyone and you can't really hear it. Again, I think the sound issue on this is not, for 99% of people, it's not an issue, but some people are more sensitive to it, or you have it somewhere like a bed near a bedroom that it's just, it's easier to pick up that sound. Insulating the piping is really important, especially the hot lines. They make that black C-clamp style pipe insulation. So certainly just wrapping all that stuff so that we're not having a bunch of heat loss through the pipes. You just bought a really efficient piece of equipment. We don't want to go just losing a bunch of heat through the piping on that. And then, as mentioned before, program this to avoid the time of use or peak power hours. Look at your bill in the top left there. It'll tell you if you're on the standard residential rate or if you're on time of use. And then, you want to avoid the 4 to 9 time period, 4 to 9 p.m. time period if you're on the standard rate, and then 6 to 9 a.m., 5 to 10 p.m. if you're on time of use. And really what you can do is on these water heaters that are coming with smart controls on them now, is you can program a schedule in there to just tell that water heater, don't heat water during those hours. And as soon as that peak is over, it'll start to heat water again. But you've got 40 or 50 gallons of stored water there that in all likelihood you can get through using without having to immediately start heating water again. And then down at the bottom here, so this is a sizing guide. This is from the New Building Institute, and really just kind of a general guideline on how to size a tank. I would say that if you have an existing tank water heater, you can, for the most part, match the size on it. You can kind of see the guidelines that they use, that they don't go to a 50-gallon tank until you're talking about 3 bedrooms, 2.5 baths, and even then you may not need it. You can purposely oversize a tank if you really want to, so that you have more hot water stored, and if you're getting close to using all that hot water, the likelihood of the backup electric resistance elements coming on is lower, so it'll stay on that heat pump more often, which is more efficient. The other option you have there is to stay with the smaller tank and then use a mixing valve like we talked about before. Tell that water heater to store at something like 150 degrees, and now it's like you have a 50-gallon tank when really you only have a 40, and yet it's completely safe to deliver 120-degree temperature water out to the home. So that mixing valve can be a great way to kind of upsize a tank without having to incur the extra cost and space of a larger tank there. So the LPEA rebate. So as mentioned, you have 90 days from the time of installation. So as soon as that installation is complete, the clock starts there. The easiest way to do it is to go on our website. There's a form embedded there. You'll see a checklist of what we need from you. We are going to need a copy of the invoice or receipt. And if it's an invoice from a contractor, it does need to have the equipment broken out from the labor costs. So just ask for that when they go to put that together for you. You also have the option there of printing a PDF out, filling out by hand, and you can either email that back to us or mail it in. And then, if you're having trouble with any of that stuff, you're always welcome just to stop in here at the office. We can print all this stuff out for you. Just bring your receipt with you, and we can get you taken care of here in the office. So the heat pump water heaters, all these systems that we've looked at, will get a $700 rebate from us. An electric resistance water heater gets a $50 rebate, but only if you're switching from propane or natural gas, or if you put a smart control on it, like the Quanta system that we looked at, or if you put a simple timer on it and you're on the time of use rate class, then we can provide that $50 rebate there as well. And then I'll also note that we have a timer rebate. So if you put a smart control on there, you get a $75 rebate to help pay for the smart control. Or if you put a timer on there, it's a $25 rebate to help pay for the timer. And if you need recommendations for what to use and how to set it up and all that, again, my contact info will be at the last slide here. You're always welcome to reach out to me and ask any questions you have. And then if you're doing new construction and for some reason you can't make a heat pump water heater work for you, if you do an electric resistance tank in there, we will provide a $30 rebate. Typically takes us about 6 to 8 weeks to send that rebate check out to you once you submit that application. So just give us time. You will see a couple of communications come from us when you submit those rebates, once when it's accepted and once when we actually send that check your way. So the federal tax program. So I think they've been talking this up now for quite a while, and this last year was kind of the first year that it really, I think, was taken advantage of and really in place. What's existing today from the feds is a rebate that covers 30% of the cost of both labor and material up to $2,000. If you happen to do a heat pump and a heat pump water heater in the same year, you're still maxed out at 2,000, but you can dip into this extra fund that's $1,200 for things like insulation and infiltration works, sealant work, energy audits, and some things like that. So there's money available there. This is a tax incentive that you would file for at the end of the year when you go to file your taxes. It's an additional form that you'll include with your filing there. And really, I would say just hang on to all your invoices and spec sheets and everything else that you have there. But that one single form is really all you need to claim that. They are asking for some performance requirements. So you'll see down at the bottom here, it's known as UEF. It's the Uniform Energy Factor. All the systems we've looked at today do qualify on this. But if you're considering something that's a little out of the ordinary and you just want me to take a look at it, I'm happy if you just email me the part number or anything like that. Just give me a call and I can take a look and make sure it's going to qualify for that system there. But for the most part, everything that we've looked at and everything that is readily available today will qualify for this tax incentive. And then, so we've got a Colorado state tax incentive as well. So this program is not quite as straightforward as the federal program. You do need to use a registered contractor for this. The way this one works is, there is a $500 tax credit for this, but the contractor claims the majority of it. So this is really kind of focused on getting the contractors to suggest these things. They are required to pass through at least $166.65 to you. So that's a third of that cost, or a third of the incentive. So this one I think is a little bit harder to actually acquire for not as much payout as maybe the Fed one does. And I think you'll find that a lot of contractors probably won't participate in this, at least probably not in the first year. So certainly if this is something that you're expecting, do ask your contractor. And there is a list up on online there. I think it's on the Colorado Energy Office website right now, where you can look up and see if the contractor is qualified for this tax credit or not. I have not seen too many on there so far. It's something I'm going to work on here in the next few months, just so that we do have some contractors available for our members. But yeah, this is a little bit harder to take advantage of than the federal one. So that's it. So that's all I had for kind of the presentation here. Let me see. I think we should have some questions. Yeah, so I've got a few questions here, and I think you have the ability to raise your hand here. Or if you just ask in the thing there, I can unmute you, or and if you want to just ask away out loud, I'm happy to answer those as well. And all three of these are actually just about the slides. So apologies for the slides not working initially. I can certainly kind of look back through these as well, just so you can all see the beginning of this. So, beneficial electrification, kind of what we were talking about there. And then the heat pump and how that all works. And I think I can make this slide deck available to you all by email. So I'll send out the recording as well as the slide deck on this. So is there anyone with questions out there, whether you want to type that into the Q&A field there, or you just want me to, I think you can unmute yourself there even, and just ask away if you have anything. And I'll put my contact info back up here as well. So that's my email, that's my cell phone. Feel free to call that. And then the rebates at LPEA email is always good. If you have general rebate questions, or you need to send in an application or some supporting documents, there's a few of us that keep an eye on that one as well. All right, I'll hang out here for a couple minutes if anyone has questions they want to ask. But other than that, appreciate everyone joining here, and hopefully you got something out of this. Again, feel free to reach out to me directly with any questions you might have. Keep an eye out for our contractor list that'll be going up on our website there for so installation contractors that are familiar with these systems to help you out. And then we'll be doing some more webinars and in-person things just all around electrification. So that's heat pumps and heat pump water heaters, induction cooktops, and electric vehicles, and all these things that we have rebate programs for, and that we're trying to promote as part of beneficial electrification. So keep an eye out for all that stuff. And thanks again for joining here. So I'll stay on here to answer any questions you might have. Oh, there's a couple in here. So this question, comparing to existing domestic water and radiant heating system, given a known BTU 65 million, how would we get to expected electrical consumption? Yeah, so you can take the COP is the best way to do it. So it's the coefficient of performance, and that'll give you the energy in versus the amount of heat back out. And a COP of 1.0 would be 1 unit of energy in, 3,412 BTU back out. So that's 1 kWh in and 3,412 BTU back out. Look at the COP on your system. So let's say the COP is a 3.0, right? I mean, with a heat pump system, we're getting 300% efficiency, which is a 3.0 COP. You can do a little bit of math there to figure out that for every kWh that you're getting in there, and I'll just do a quick math, 3,412 times. So for every kWh at a 3.0 COP, you're getting over 10,000 BTU back out. And so you can kind of back into a number that way. The coefficient of performance, that COP rating, is going to be at a specific temperature. So they typically rate it at something like 5 degrees outside ambient temperature. And obviously we're not at 5 degrees Fahrenheit all season, so you can expect to be a little bit higher than that. But certainly that'll give you kind of a ballpark number on where you're at on that. If you're talking with a contractor, or you're dealing with someone like Arctic Heat Pumps or something like that is willing to work directly with the consumer, they should have some software that'll crunch those numbers for you and figure out exactly what you need and how much it's going to produce. Yes. So estimated pricing for the smart control. So that Aquanta controller goes at retail 150. I think I've seen it on sale before, and you may be able to get it through a distributor for less. And the mixing valve, it's probably DIY install, I've seen them equipment only sell for something like $80. Whereas, if you have a plumber come out, it's probably going to be, 250, something like that. So yeah, I think the cost effectiveness of the electric resistance tank plus the smart control plus the mixing valve, I think you could get a heat pump water heater with all the tax incentives and rebates and all that, for probably around the same cost. So really, I would only suggest going that route if a heat pump water heater just doesn't work for you. Yeah, and Carla, definitely, yeah, we'll send out the recording here, to your email address. So whatever you registered with, we'll send that out to you. And that's all the questions I'm seeing so far. So I'll hang out for just a couple more minutes. Got it. Yeah, Carla, I'll add that to the list. Thanks. Yeah, so on the LPA website is a straightforward way to pull our surplus solar generation. So the best way to see your surplus is going to be through Smart Hub. If you don't have that already, that's kind of the best tool we have right now. That will show you your net export. So if you're producing more than you're consuming, that's when you'll see it drop below that x-axis. Otherwise, if you want to just see how much you're producing in general, the inverter, so if you have an app through your inverter, that'll tell you for sure. And then if you're really curious on what you're using versus what you're producing, there is an energy monitor out there that can do both production and consumption. It's actually I've got one sitting there in the background. It's from a company, and that is the Emporia View 2 energy monitor. And that can do both production and consumption, and it'll attach to each of the different circuits there, to tell you exactly what you're using on your, whether it's your heat pump, your fridge, your stove, your induction cooktop, whatever. Breaks all those down so you can see how much you're using and when you're using it, and what you're producing through solar. So if you're ever interested in really getting granular with that usage and figuring out where all that energy is going, the Emporia system is pretty nice for that.